Here is an explanation for the answer to final exam question number 32 in Electricity Demystified, second edition. Please refer to page 328 of the printed book. We're talking about a solid copper wire, presumably with a circular cross-section. Solid, pure copper. The diameter is D. The DC resistance of a fixed length of this wire, another way of saying that is the resistance per unit length, varies how? And we're given 5 choices. Well, the quick and easy way to think of this is to think of conductance instead of resistance. The conductance per unit length of a wire like this varies in direct proportion to the cross-sectional area of the wire. So, if we double the cross-sectional area, we double the conductance. So, we cut the resistance per unit length in half if we were to make the diameter 1/4 as great. Now remember, the cross-sectional area of a disc-shaped or a circular wire like this varies according to the square of the diameter. So if we double the diameter, we quadruple the cross-sectional area, so we would quadruple the conductance per unit length or cut the resistance per unit length to 1/4. So in general, the resistance per unit length of a wire like this varies in proportion to the inverse square of the diameter. So if we say cut the diameter to 1/5 of what it was, then we cut the cross-sectional area to 1/25 of what it was, and that means we would increase the resistance per unit length by a factor of 25. Now we assume always that the cross-section remains circular and the wire remains of uniform diameter, solid, pure copper all the way. So the correct answer to this question is A. The resistance of a fixed length of this wire varies inversely in proportion to the square of the diameter. Again, so we double the diameter, then we cut the resistance per unit length to 1/4 of what it was. We cut the diameter in half, and we quadruple the resistance per unit length, and so on. You can figure it out from there. Again, the choice is A.